Okay, so last Friday, you guys learned about the ideal gas law and also kinetic theory of gases. Okay, so can anyone tell me what is the ideal gas law? You guys, if the video was helpful. You guys know
PV
what?
equal to nRT.
Okay, PV equals to nRT. So what is P, what is P, what is V, what is nRT?
P is pressure.
P is pressure. Thanks, Afika. P is pressure,
V is volume.
is volume. N is
Mole
Number of
of
moles.
gas.
number of moles of gas. Okay. R is
Universal gas constant.
universal gas constant, and the value, you don't have to memorize the value, but it is 8.3, I don't know, 71 kot. 14 kot. Tak tahulah saya. Okay, but it's there in the book. And this should be in joules per mole K. Kau kat sebelah saya. Okay, nanti kita akan go through lah. R, and then we have T, which is in Kelvin. Okay, so T is in Kelvin. So if N is in mole, T is in K, this guy is in joule, P is in pressure, V is in volume. Will it give me joules? Patutnya. Okay. So that is your, okay, what should be the unit for pressure? Should be Pascal, not ATM. Tapi saya rasa dalam video saya cerita pasal ATM kot. But it should be in Pascal, which is your SI unit for pressure. Okay. Volume should be in meter cube. Mole is mole lah. Okay. Mole. Universal gas constant. This is the unit, I think. Nanti kita check balik. Kelvin, temperature is usually in degrees Celsius. But for the ideal gas law, we will use Kelvin, which is K. Always, always Kelvin for this chapter. Okay, moving on. Wait, is it always for this chapter? For heat. Okay, tak apa. KIV dulu. But for this equation, T is Kelvin. And then we also learned about when we change one of the parameters in the okay, let's say we have a gas. Okay, why is this gas like randomly there? So we have a gas in a box. We have learned that if we expand our box, which means that we also expand the volume, we are changing the gas state, right? When we change the gas state, some of the other parameters will change as well, and it is based on this equation. For example, if I increase volume, something needs to change. It can be pressure goes down, or can your N ever change when you increase the volume?
No.
No, because N is almost like a mass. Any mole, but you can view it like a mass, and mass does not change from, it doesn't change lah. So mass does not change. So you can view it like that. So when you increase the volume, N is constant, R is constant, T, we don't know if it's constant or not. So something has to change. It can be either P, it can either be T. So it's the same case if you change P, something else has to change. If you increase P, V has to change or T has to change. Okay, something has to change. You cannot change one state and expect the rest of the parameters to not change. So these changes follow the ideal gas law. Okay, why is it called ideal? Because we approximate the behavior of real gas at standard temperature and pressure as ideal gas law. Okay, nanti kita akan cakap pasal STP, standard temperature and pressure. We will talk more on this later. When it is at STP, we can use PV equals to nRT. However, at super high temperature or super low temperature, we can't use PV equals to nRT because at those states, the interactions of the gas molecule becomes complicated. There are a lot of things to factor in. It's not just kinetic energy. There's like a bunch of other forces lah. Okay, maybe the gas interacts, which is how you when you heat up something, you actually form a new substance. That is, benda tu dah jadi complicated lah. So you can't use PV equals to nRT in those cases where you are at extremely low temperature or at extremely high temperature. Okay, selalunya the gas molecules will interact with each other. So you can't use PV equals to nRT. So PV equals to nRT ni untuk cases yang very mild, for gases that are in random motion but not in high density. Okay, it is at low density, moves in random motion. What else? We talked about this in kinetic theory. Let's add slide. So we talked about this sebelum masuk kinetic theory. So the characteristics of ideal gas should be it's diluted lah, diluted or low in density. Okay, so dia tak concentrated. If you know, if concentrated gas, usually they are in liquid form. So no, we are not looking into those situations. We are looking at gas biasa je lah, not in like special circumstances. Moves in random motion. Okay, random motion, and this is called Maxwell distribution. Follows the Maxwell distribution. We will also talk more on this. Saya just highlight sikit-sikit dulu. Follows Maxwell distribution. What on earth is a distribution? This is statistic. I'm not sure if you have started learning statistics yet or not. What else? Can anyone help me? Diluted, low density, moves in random motion. No interaction between the molecules. Okay, no interaction or forces between the molecules. What happens when they bounce off the walls of the container?
No energy loss.
No energy loss or elastic collision. Thank you. No energy loss when bouncing off the walls. Okay, so, or elastic collision. You have learned this in last semester. Have you? Okay, I think so. Kita dah belajar elastic collision kan last semester? Momentum belajar last semester kan? Betul lah tu. Okay, elastic collision. Lepas tu, what else?
Each particle of ideal gas is point light.
Light.
Point light.
Lagi sekali, tak dengar. Sorry.
Each particle of ideal gas is point light.
Oh, point light. Okay, okay. So betul-betul. Gas molecules are point light. Gas molecules are point light. Okay. Point ni penting untuk lab virtual. Gas molecules are point light, which means that they are negligible in volume, and volume means space and mass. Ini untuk ideal gas sahaja. Real gas ada dia punya own mass, ada dia punya own volume, right? But for ideal gas, we are assuming that the gas molecules are point light. Point light tu apa? Macam satu titik ni, satu titik, macam kecil gila lah. So it means that they are negligible in volume and mass. So we don't really care about their mass when we use PV equals to nRT. We don't care about the mass. Okay. Oh my god. Macam tu pula. Okay, so satu gas molecule, negligible volume and mass. However, when they are in a system, adalah volume dia. So this dia nak cakap macam hydrogen to krypton gas. Mass dia sama je sebab dia pakai PV equals to nRT. Tapi sebenarnya in real situation, it's not the same. But PV equals to nRT makes this assumption that all gas molecules are point light, meaning to say we don't care about their masses, to simplify the calculation. Okay? Ada sebabnya kita simplify. Kalau tak memang jadi complicated sangat semua benda. Okay, so we tend to simplify things for to make our lives easier, I guess. Okay, so that is your kinetic theory. Sorry, that is the characteristics of ideal gas. Okay, new slide. So now we move into kinetic theory, punya equations. So I told you the kinetic energy of a atom or a molecule is 1/2 mv squared average. This is for one atom or one molecule of gas. Nampak tulisan saya buruk sangat ni. One molecule of gas. Okay. So when we want to find out what is the kinetic energy of a system of gas, maksudnya ada banyak lah kan? Ada a lot of molecules. So what is the total kinetic energy? It becomes Ke equals to N 1/2 mv squared mvg squared lah. Okay, so basically you times the kinetic energy of one atom or one molecule with the number of molecules in the gas system. Okay. So kita tak go through ni lagi rasanya. And then we talked about V RMS punya equation. Ke is also equal to 3/2. Was it KT? Yep. And this is 1/2 mv average squared. And I told you V average squared basically means V mean and squared is squared. So if I want to find out what is VRMS, I have to include a root square. Sorry, I have to include a root square and root square. No, I have to include a root. This is the average. This is the square. Okay, root, mean, square. So this guy is already mean. This is already squared. I have to put in a root there to make my VRMS, to find out what is VRMS. Okay, so 3/2 KT. I'm just going through this laju-laju je. V average squared. So 2 part cancels out. M goes here. 3/m. 3 KT over M. I want to put in the root here so that I get the VRMS. So what happens now? Tak cukup tempat lah pula. Okay, let's use a different color. 3 KT over M equals to VAVG squared. I want RMS. So what do? I put in this root here. So now it becomes VRMS. So this V average squared root is equals to VRMS. So 3, if I root here, I have to root here as well. 3 KT over M. Okay, so I hope this is clear. Jangan confuse pula pasal equation ni. Just use the equation as it is. VRMS is equal to 3 KT over M. Or we have learned that K is equal to R over NA. So just substitute that into the equation. So VRMS is what? 3R over NA times T times mass. So NA times mass gives you the molar mass because NA is Avogadro constant per mole, the number of molecules per mole. So this will give you molar mass. So 3RT over M, capital M, squared. Sorry, this should be squared as well. So you have two versions of the VRMS equation. Is that clear? Is that okay for everyone? Okay ke? No answers? Everyone's confused?
Okay.
Okay.
So ada dua version yang kita belajar dalam video is 3 KT over M. But you already know that K is equal to R over NA. So just substitute R over NA into the equation. And NA times mass is just capital M or the molar mass. Okay, it's pretty easy. Tapi benda ni datang daripada chemistry lah. Okay, so hopefully you still remember. Okay, so phases of matter, solid, liquid, gas, you know this already. Mole, N, and Avogadro's number, we also talked about this already. Mole is, the symbol unit is N. The unit is mole. Okay, so Na is the Avogadro constant, 6.022 times 10 to 23 atoms or molecules per mole. So this is 1 mole kan. So 6.022 times 10 to the 23 atoms or molecules. This is the number for a mole. Okay. So n moles is equal to n, the number of molecules in a gas, over Na will give you n moles. So I believe this equation is in your textbook as well. I mean your module book as well. Okay, so this is calculating the mass of a molecule. I don't think you should know this for your syllabus. Ini dah belajar dalam chemistry kan? Should be, right? Ke belum belajar?
Belum.
Hah, belum? Ush. Yang ni belajar tak? Yang n equals to n over Na ni.
Belajar.
Okay, thank God.
Ada.
Okay. We are not going to use this one untuk buat web assign or for your test. So I'm just going to skip this one. But here you need to know this one. N, capital N. Capital N is the number. Okay, it's here. Capital N is the number of molecules. M, capital M is the molar mass, molecular mass of substance, mass per mole. Mass over molecule, sorry. This should be mass, Avogadro number times mass. This is molar weight. And A times mass gives you molecular weight of 1 mole, molar mass. This is molar mass. Okay. So molar mass times, betul lah, tadi silap. Saya yang silap. Okay, betul. So number of molecules times the molar mass of the substance, mass per molecule. Okay, will give you molar mass. This is molar mass. Okay, so that is good. This equation penting because you will use it if you can't remember all the equations, you will have to remember this one in particular to substitute into the equation. Macam beat the purpose lah pula kan. But equation ni penting lah. Okay, not just in physics, also in chemistry. Biology, I'm not sure. Okay. So the learning outcome for this subtopic is for you to state ideal gas and solve problems on ideal gas. All right, so let's do that. So ideal gas is a dilute gas, no interaction. We talked about this. They move in random motion. Each time it collides, there's no energy loss. We make this assumption to make our lives easier. So most gases are at room temperature and atmospheric pressure. Behave like ideal gas, okay? So 3 physical quantities determine the gas state, which is pressure, temperature, and volume. Okay, PV equals to nRT. So we have temperature, we have volume, we have P. 3 basic gas laws that derive the relationship between the physical properties of a gas. So these are the laws that these different individuals came up with. And then when we combine all these laws together, we get the PV equals to nRT. Okay, so diorang buat sikit-sikit je. This guy buat sikit, this guy buat sikit. Lepas tu diorang combine all these laws together to make the ideal gas law. Okay, so what is Boyle's law, Charles' law, and Gay-Lussac's law? So Boyle's law talks about volume of a gas is inversely proportional to its pressure. So P is proportional to 1 over V, or PV equals to constant. So when you put V over here, this side dah tak ada apa-apa kan, so it becomes a constant. So PV equals to a constant. So from one state to another, from one state to another, let's say you start with P equals to 1 Pascal, P1, V2 equals to, yes. Okay. And then you start with 10 meter cube. And then they give you what is the volume at pressure?
What's that?
10 Pascal.
What's that?
Oh, wait. So what is the pressure? What is the volume at this pressure? So you are going from state 1 to state 2. Okay, so this is when you use the equation. You are going from state 1 to state 2. P1 V1 equals to P2 V2. Okay, Nanti saya akan ajarkan trick macam mana nak ingat benda-benda alah ni lah sebab there's a lot. Okay, so and then the next one is Charles' law. It talks about, nah, take it. Can you close the door, please? Nah. Okay, volume of a gas is directly proportional to its temperature if its mass and pressure are constant. So V is proportional to T. So when V increases, temperature also increases. This is what Charles' law said. So again, if I have a state volume, I start with 10 meter cube, and then the temperature is 325 Kelvin. And then I give you a temperature of 400 Kelvin. What is the volume at this temperature? So you use this equation, V over T over V1 over T1, V2 over T2. Okay. So we are assuming all the other parameters are constant except these two guys, V and T. Okay, so this is Charles' law. And then Gay-Lussac's law is P is proportional to T. If P increases, T increases, or if T increases, P increases. So again, moving this guy to the other side gives me a constant over here. So I can say P1, T1 equals to P2, T2. Okay, so this is Gay-Lussac's law. Do you have to memorize the names of these individuals? Not really. Just have to know like in general, like okay, ada 3 orang yang buat gas law ni kan. Okay. That's fine because I don't remember their names either. Okay, so you just have to know in general that they make up all these different laws to make the PV equals to nRT. Okay, so PV, kita dah belajar PV equals to P1 V1 equals to P2 V2, V1 over T1 equals to V2 over T2, P1 over T1 equals to P2 over T2. Then combining this will give you PV over T is a constant, and constant to nR. Put this guy over here, you get the PV equals to nRT. Okay, it was basically that lah. So how do you remember the Boyle's law, the Charles' law, the Gay-Lussac's law, right? Because I mean like banyak kot. So how do I do this? This is my trick lah. If you guys have a different trick to memorize these things, go for it. I'm just telling you how I do it. So we start with PV equals to nRT. So if the question says, okay, hey, if the question says volume is constant, kejap macam ada commotion pula kat sini. Okay, so we start with PV equals to nRT. If the question says, okay, your volume is constant, which means that this guy is a constant, right? It belongs to the constant side. So N is constant, your mole does not ever change, your R does not change, it's a universal gas constant. So if the question says, okay, volume is constant, so you know that, okay, this guy, let's move it to the other side. So this will leave me with PNR over V, and they did not say T is a constant, so T should go to the other side where it's not a constant. So T goes here. So this gives me P over T equals to nRV. Okay, again, so the question said V is a constant, right? So this means that P over T is equal to a constant, and you should be using P1 T. You should be using P1 T1 equals to P2 T2 to solve the question. Okay, so this is when volume is constant. V is constant. Macam tak sesuai pula tulis kat sini. Okay, kejap. What? Sun, okay. Okay, can close the door please, thank you. Weh, kuatnya. Okay. Okay, so this is when volume is constant. Let's put it here. And my phase, I put it here. Okay. Okay, moving on. The next situation, what if your temperature is constant? What should you do? So PV equals to nRT, always start with your ideal gas law equation. T is a constant, which means that nR times T is all a constant. So what equation should you use? You should use PV, P1 V1 equals to P2 V2, okay? This is when your T is a constant. So let's write, kita buat indicator sikit lah. So this is volume constant. This is T constant. What is the next one? P is constant. So P is constant. By now, I think you know the trick already. Senang je kan? So let's use green now. So PV equals to nRT. What should we do here if P is constant? Come on, guys. What should we do here?
Move P to the right side.
Move P to the right side. Yes, because it is a constant. What should go to the other side though? To the left side.
The T.
E. So now I get V over T equals to nR over P. And we know that this guy is a constant. Sebab dia cakap dalam soalan. So we use the V1 over T1 equals to V2 over T2 equation. Okay, sometimes you have to use the PV over T equals to a constant. Maksudnya semua kat sini tak constant. Ada juga cases macam tu when PV and T, all of it is not a constant. So this is when you use P1 V1 T1 equals to P2 V2 T2. Okay, so this is when no constant except N and R. Okay, so fahamlah no constant tu maksud apa Maksudnya P, V and T tak constant. Okay, so moving on. I hope that trick was helpful. Nanti kita akan go through an example later. Okay, so ideal gas law. I told you that ideal gas law, the ideal gas law applies for gases at standard temperature and pressure, which is T equals to 273 K, 0 degrees Celsius ke? 273, 0 degrees Celsius or 1 atm, which is 101.3 times 10 to the 3 Pascal. Kalau buang K ni lah. 101.3 times 10 to the 3 Pascal, or yang korang biasa tengok 1.013 times 10 to the 5 Pascal. Sama je. Okay, so this is at 1 atm. Standard temperature and pressure is 273 K, 1 atm or 1.013 times 10 to the 5 Pascal. And the volume of one mole of gas at STP is 22.4 times 10 to the minus 3 meter cube or 22.4 liters. The volume of 1 mole of gas at STP is this. Okay. Okay, so R is 8.314 joules per mole per K. Say joules per mole per K. Macam tu This is called the universal gas constant. We've seen this before. Ideal gas law states that volume V occupied by n moles of gas has a pressure P at temperature T can be described by the equation state PV equals to nRT. Okay. So an alternative equation for ideal gas law is just substituting the R for K, R over NA, this one. Okay, substituting R for K and A because kita belajar K equals to R over NA. Kalau kita nak substitute for R, so this guy moves to the other side. R is K and A. So dalam equation ni akan jadi kena adjust sikit lah. So PV equals to capital N K T. Okay. And A ni akan disappear. Macam mana tak ingat. Oh, this guy. Dia tulis kat sini. So PV equals to nRT. So N, Kita skip it first. K and A, T, PV doesn't change. So N times NA, N times NA gives you capital N, the number of molecules. Moles times Avogadro constant, the number of moles times the Avogadro constant gives you the number of molecules, the total number of molecules, and that is N darab dengan NA akan dapat capital N, KT. So this is another version of PV equals to nRT. If you want to use it lah. If you don't want to use it, that's fine as well. Yang penting kat sini is remembering K equals to ni. Okay, then it's easy for you to switch around. And also the equation yang N benda dah tu. Mana dah pergi? This one. These two equation and K equals to R over NA is very important. If you want to switch around the equation to other versions, you just have to know these two. Okay. Okay, so real gas are not ideal gas. Kita buat assumption je. Even at ordinary temperatures and pressure, real gas can deviate slightly from the ideal gas law. So this is a PV diagram. We call this a PV diagram. It has P pressure for the y-axis and volume for the x-axis. So meter cube, this guy is in Pascal. This should be in pressure. Please don't label P and V in your jawapan. Kalau kena tulis, if you have to sketch the PV diagram, don't label P and V. Please label pressure dalam kurungan Pascal and volume dalam kurungan meter cube. Kalau letak P and V je memang tak ada markah because I don't know what P is, don't know what V is. Is it I don't know what is V. Okay, you have to tell me what is V. So this is the ideal gas law punya curve. It follows the PV equals to nRT. Real gas, dia berombak-rombak lah. It doesn't follow exactly the ideal gas law. So again, ideal gas is based on assumption to help us calculate things, make our lives easier. Yang sebenarnya real gas has a lot of fluctuations. Kita punya temperature pun tak standard. Our pressure is also not standard. Ada yang pressure tinggi sikit kat sini, ada yang pressure rendah sikit kat sini. So again, we are just doing this calculations based on easy punya assumptions. Okay, so let's do this one. Ideal gas law. This is an example. Find the final volume of, so this we start with this guy, so V1, 200 centimeter cube of nitrogen gas if its pressure. So he wants us, this question wants us to find what is V2, our final volume from 200 centimeter cube. If its pressure is increased from 1 atm to 2 atm, so P is also given. 1 atm is the initial pressure and P2 is given 2 atm. So what equation should I use to solve this one at constant temperature?
PV
Boil.
equals to V.
Okay, boil. Boil is PV equals to PV. P1 V1 equals to P2 V2. Macam tu ke? Okay. So if you don't remember, you can't come up with this equation terus, use the method that I told you. PV equals to nRT. So T is a constant. All of this is a constant. So yes, P1 V1 equals to P2 V2. Macam tu So now what is the next step that I should do? Can I just plug in these values?
No.
What should I do?
Convert to Pascal.
Convert to Pascal, betul. So 1 atm is 1.012 times, 13 times 10 to the 5 Pascal. And this guy is 2.26 maybe, 10 times 10 to the 5 Pascal. Okay, so can we use volume in centimeter cube?
No.
Should we use in liters?
Meter cube.
In meter
Meter.
cube, yeah.
Meter cube.
Okay, so how do we convert centimeter cube to meter cube. Okay, let's do this together lah. So everyone, please pay attention on how to convert 200 centimeter cube. So we have centimeter in cube form. If I want to convert cm to meter, it is I have to divide by 100, right? So cm, so 100 centimeter is 1 meter, which means that to convert it to meter, I need to, darab dengan 1 meter over 100 centimeter. This is how I convert 1 centimeter cube, 1 centimeter to meter. Okay, kejap, sabar. So 100 centimeter is equal to 1 meter. Okay, so using this, I know that 1 meter is 100 centimeter, and I want to get rid of centimeter. I want to get rid of centimeter, and I want meter. So if I want to get rid of centimeter, my centimeter should be at the bottom. However, benda ni satu je. This guy is 3. So kalau saya nak buat cara yang panjang tapi tak serabut, I can do this. Times 1 meter over 100 centimeter. So now I have 1, 2, 3 centimeters cancel out. I have 1, 2, 3 meter cube now. So 200 divided by 100 divided by 100 divided by 100 will give me meter cube. Okay. If you don't want to use this method, it is also fine. You can just directly use 1 meter over 100 centimeter, and then you just cube this thing. When you cube it, this guy becomes 100 times 3 juga kan? 100, 100, 100. Sama je sebenarnya. Okay. So 200. So this is 200 centimeter cube. Centimeter cube cancels out. I am left with meter cube. This 100 needs to be cubed as well for you to solve this. Okay. So this is method panjang, jawapan sama. Method pendek, but take care lah to really multiply everything. To really cube everything. Okay. Kadang-kadang terlupa 100 ni pun kena cube. This is the mistake that I usually notice students make. So this is like the most, how do I say this? Benda yang susah nak salah lah. Okay. So please use this if you think you have trouble converting. Okay, so 200 divided by 100 divided by 100 divided by 100 will give me, what, 200 times 10 to the minus 6. Maybe, no. 1, 2, 2, 3, 6. Yep, 6 meter cube. Good, I think. Kalau salah, tolong betulkan. Okay, so that is 200 times 10 to the minus 6 meter cube. Okay, now I can use the equation. Nampak macam senang je kan? Tapi ada juga orang salah. So this is why I go through these questions walaupun macam senang. Sorry. Okay, so V is 200 times 10 to the minus 6. P2 is 2.026 times 10 to the 5. And this guy is, we are trying to find it. Okay, so V2 should be in meter cube. So this is tanda soal. I don't know. I didn't do the calculation. Who's that Pokemon? I don't know the answer. So this is the answer. So 100 centimeter cube. They converted the 100 times 10 to the minus 6 meter cube to centimeter cube. Pun boleh. This is acceptable. This is acceptable. Okay. Both works. Any questions about this one? Is everyone okay with that question? Am I going too fast?
Okay.
Am I going too fast?
No.
Okay, kalau ada soalan, tolong just interrupt me. Okay, so next example, what is the volume? Tanya, what is the volume of 1 mole of gas? So N is equal to 1. Of helium gas at pressure 1 atm. Pressure is 1 atm, but we know we have to use in Pascal. So 1.03 times 10 to the 5 Pascal. And temperature of 303 K. So T is 3:03 What time is it? Oh, okay. So what equation should I use here?
PV equal to nRT.
PV equals to nRT. Why? Kenapa tak ada P1, V1 equals to P2, V2 ke whatever, the one state to another?
Because
Because
it have
it didn't state that P or T or V is constant.
It didn't state that P or V or T is constant. Okay, betul juga. Okay, so let's try. PV equals to nRT. P is 1.013 times 10 to the 5. V, we don't know. N is 1. R is 8.314 joules per mole per K. And T is 303. Okay, so V should be, we don't know, but it should be in meter cube. So let's see the solution. Okay, so this is how you do it. Betul. So the equation that we use is correct. So PV equals to nRT. Okay. Okay, so this is an exercise. Let's do this. I mean, I want you guys to try. Kita akan discuss. I'm gonna give you guys. Sekejap, yang ni senang ke susah? Okay, yang number 1 is easy. I'm gonna give you 5 minutes for that one. Exercise 15.2 is a little bit tak susah tapi complicated sikit je. So 7 minutes on that. So 15 minutes total lah. Okay, so 15 minutes to do this. I will call out someone as usual. Let's do the first one first. 15.1. 5 minutes. Easy peasy. While I drink. 5 minutes, huh? So what time is it? 12.27. So let me call out someone by 3-2. Oh my God, perhaps me. Okay, one more minute. Excuse me. Okay, can I get Nurhan? Is Nurhan there? Is Nurhan there? Ada? Tak dengar suara awak Nurhan. Okay. Kuat sikit. Boleh tapi awak kena kuatkan sikit suara. Boleh je saya dengar. Sekejap saya buang ni sekejap. Let's solve it. Did you get the answer?
Yes.
Okay, that's good. Sekejap So what was the equation that you used for this question?
Over T1 equals to P2 over T2.
Dengar pun. Okay. P2 over T2. Okay, kenapa? Why did you decide that this was the question? This was the equation to use? Kenapa volume kat sini? Because? Agak-agak aje. Salah tak apa.
Sebab dia macam bandingkan. Itu kalau P ni lepas tu dia bagi temperature, lepas tu dia macam bandingkan je lah.
Okay, so cara awak is like awak nak bandingkan dua ni je lah macam tu. Okay, can anyone help Nurhan on why the volume is constant here? Betul Nurhan. Awak punya jawapan tu betul juga. But why is the volume constant in this question?
It does not mention.
Because it's not mentioned. Okay, boleh jugalah macam tu. Okay, but the actual reason is that your tire kereta, kita selalunya kisah pasal pressure je kan. Kita akan assume dia punya volume either tak berubah sangat ataupun tak berubah. Betul tak? Kalau volume kereta awak berubah-ubah, kalau volume tayar berubah-ubah, maksudnya kereta tu terangkat ataupun menurun kan. So usually you have like an approximate volume that you know is true for the tire of a car. So kita nak cakap, what I'm trying to say here is that the volume of a tire of a car does not change much. If it changes a lot, maksudnya kereta awak akan ke bawah ataupun ke atas and it changes with the pressure. So here kita akan assume the volume is constant. But what Nurhan said was true as well. Kita nak bandingkan dua ni je. So bandingkan dua ni je lah. Okay. So P1, okay Nurhan, please continue.
Lepas tu saya gantikan Celsius tu pada Kelvin.
Okay, which is?
298.
298 K, okay.
Ya, 50 tu sama dengan 323.
323. Okay, alright.
Lepas tu yang ATM tu ganti pada Pascal.
Okay, which is?
Dapat berapa? Saya dapat 1.2.
1.2. Darab?
Darab 10/5.
Okay, this is in Pascal. Okay, so using these values, dia akan Nurhan akan substitute 1.2 times 10 to the 5 Pascal over temperature 1 298 K equals to P, kita tak tahu, kita nak cari temperature 323. Okay. Sorry. 323 K. So P2 will be in, I don't know, in Pascal. So let's see the solution. Thank you, Nurhan. Okay, so this is in Pascal, betul. This is the what Nurhan did. Dia tukar jadi Kelvin. Dia solve for P1. Absolute pressure when the temperature, what is when it's temperature. Kenapa dia solve for PI? Kejap. TI is, oh okay. Dia terbalik. Okay, tak apa. Asalkan jawapan dia betul lah. So Nurhan dapat jawapan ni tak?
Dapat.
Dapat okay. So the equation that Nurhan used is correct. The conversion he did was correct as well. So good job Nurhan, thank you. Okay, moving on to the next one, exercise 15.2. Where the balloon is filled. Wait, what happened to my mouse? Okay, where the balloon is filled with 0.1 meter cube of helium at absolute pressure. So we have volume 0.1 meter cube, absolute pressure of 10 atm. So P is 10 times 10 times 1.013 times 10 to the 5 Pascal. Temperature of 20. So T is 20 plus 273 K. So it is asking, the balloon is led to rise. Mula-mula dia dekat sini, lepas tu dia, lepas tu dia naik atas, led to rise as it rises, the gas expands. The V increases when it rises. Okay, the gas expands to the temperature change with altitude. T also changes. So let's use this. V changes, T also changes. Delta V, delta T. The temperature reduces to minus 10 degrees Celsius. So T minus 10 plus 273 K. Pressure is P1 times 1.012 times 10 to the 5 Pascal. What will be the volume of the balloon at this height? What is the final V? Okay, can you guys, I'm going to give you like 5 minutes to figure out the equation to use and the steps and the final answer. Okay, 5 minutes. So 45, 12:45. What equation should you use here? Just senang je kan? What is its radius? Okay, macam lama pula kan? Soalan senang. Does anyone want to volunteer? Or should I call out someone? Can I ask? Sorry, saya cheating sikit. Can I ask? Mana pergi list? We missed someone. Ada orang keluar. Can we get? Is Jaya here? Cik Jaya aja kan? Sorry lah Jaya, saya dah panggil awak dah banyak kali dah. Okay, saya tukar orang. Oh, Hidayah masuk. Admit. Can I get Danish pun dah pernah. Siapa yang belum? Hajar, Siti Hajar. Saya rasa belum kot. Siti Hajar belum kan? Is Siti Hajar there?
Yes.
Tak pernah panggil awak kan? Okay. Takut je nak jawab. Okay. Can you help me solve this one? How did you do?
The formula that I use is P1 V1 over T1 equal to P2 V2 per T2.
Okay.
And we evaluate the equation that we need to find is V2. And the equation will be P1 V1 over T1 multiply T2 over V2. And we substitute the value.
Okay. So jawapan awak sama tak?
Sama.
9 meter cube. Okay, I hope everyone used the same equation that Hajar used. Thank you, Hajar. Let's see the solution. Yes, it's correct. Okay. Senang je kan? This subtopic is easy lah sebenarnya. Right? I think. I hope so. I hope that is the case for you guys as well. And we already learned how to use the trick to finding out which equation to use. Okay. Find out what is the constant and then move to one side. The side on the other side, the left side is the ones that are not constant. Okay. So please use that trick if it helps you to identify the right equation. Okay, so moving on, kita ada 15 minit lagi. So baru nak masuk kinetic theory of gases that we have learned last week little bit. So for this subtopic, we need to understand how to explain and calculate the internal energy of a gas using kinetic theory. And the equation related to this is VRMS, average kinetic energy, and also U. U equals to internal energy of the gas system lah. Okay, so U, right? So kinetic theory of gases explains the properties of gases in terms of the motion of the particles. Why motion? Because it's kinetic energy. Kinetic is related to movement. So the kinetic theory of gases explains the properties of gases in terms of the motion of the particles. And the assumption is based on the ideal gas characteristics lah. Ideal gas characteristics kat sini is just repeating what we have learned in the previous subtopic. So very small, the number that makes up the system is very large, moves in random motion, follows Maxwell distribution. We will see what that is. Collision is elastic, no attractive or repulsive forces. Kinetic energy depends on the temperature of the gas. Now this is new. I did not mention this while we are learning about ideal gas law. The kinetic energy of molecules is dependent to the temperature of gas. Kita akan tengok about this one. Okay, moving on. So the random motion of gas molecules. So we have all these gas molecules in the air. It moves randomly. So how do we predict its behavior? How do we predict its behavior if it's always moving randomly? So this is where we use statistics to say, okay, the probability of this molecule to move at a certain speed is this much. The probability of this molecule to move at a certain speed is 0.1. Maksudnya, statistic tells us, macam it gives us prediction, bukan prediction, probability lah kot. I don't know if that's the right word. Gives us the probability of a certain occurrence to happen. Probability for something to happen. Okay, so here, if we look at this graph, we see that the velocity at the velocity at 500 meter per second is the highest. Okay, the velocity 500 meter per second is the highest, which means that the number of molecules in a gas system most of them will be at this speed. Okay, let me rephrase that. I have a box. Okay, I want to know what is the speed of the gas molecules inside this box. But of course, I know it's random and it follows the Maxwell distribution. Okay, so I will say that most of the gas molecules inside this box will have a velocity of 500 meter per second. This is 30%. Let's say this much is 30%. So 30% of this box, of this volume of gas, will be from 0 to 200 meter per second. And let's say this is 20%. 20% of the volume of this box will be at speed 200 to 500 meter per second. And if I want to say this whole part, 50% of this box will have a speed of 500 to 1000 meter per second. So statistik ni dia kasih probability je. Sebenarnya tak tahu betul ke tak. But that is what they get from the data analysis lah. So is it helpful to have distributions? Yes. Because benda yang random sangat susah untuk predict. So when we have distribution, we can say, okay, maybe 50% it will happen this way. Maybe 30% it will happen this way. So when they ask us, how do you know this happens this way? Oh, based on this distribution, it says there is 30% probability that this thing will be happening. So distribution helps us that way. I know this is like, dia doktor cakap ni. Just bear with me. So statistics gives us probability. Gives us probability. I mean, that was a poor attempt at explaining maths because maths is not my area. Okay. So if you divide. So this is, the entire curve is 100%. So sorry for the slamming of the door. That was my son. So this is 50%. This is 50%. I want to know what is 10% of the gas in this area. So 10% of gas in this area will have a velocity of 390 to 400 meter per second. So that is how you use distribution. You look at the graph, check out, okay, I want to know what is this much doing? What is this much doing? Okay, so I don't know if this is helpful, but that's a general knowledge for you. So the ideal gas follows the Maxwell distribution. Whatever inference that we have about kinetic energy, we use the Maxwell distribution to justify our work. Okay, is it important to know what is Maxwell distribution? No, I'm just giving you an idea of it. Okay, hopefully your math teacher will explain that better to you. Okay, so this is the graph that we talked about earlier. I told you most of the gas particles will have a speed of 500. However, when the temperature is increased, this graph it shifts to the right. It shifts to the right. and it changes shape. So now 50% of the, is it 50%? 50% is, okay, 50% of the gas in the system will have a velocity around 700 meter per second. Previously, it was at 400, which means that as I increase the temperature, the velocity of the gas particles also increases. Okay.
Okay.
Sipu je. Okay, so a system of a gas at a given temperature will exhibit a variety of speeds, VMP, V average, V RMS. Okay, just bear with me. I know this is like, oh benda ni, Allah kan. I would say the same thing. So VMP is most probable speed. Okay, sabar dulu Benda ni untuk kefahaman akan datang. Most probable speed, VAV, AV. VAV is average. Okay, average speed, you know this. You are most familiar with this one. VRMS is root mean square. And kita dah belajar pasal ni juga. How is average related to root mean square? Average is mean. So to make a V average to become root mean square, I need to add the square, I need to add the root to make VRMS. Okay. So here, what you need to know is as the temperature rises, these three speeds shift to the right. We talked about this. Velocity is proportional to temperature. If my temperature increases, my velocity also increases. Sebab kinetic energy. Hence, as T increases, V also increase. Okay, V as in velocity, not volume. Keep moving on. So here, do you need to know this? Tak payah tahu pun tak apa. For gases, the root mean square RMS speed is most suitable. Why? Because it takes into account both